Welcome to the webinar. I'm Larry Boyhumer. In this one, we are doing part 2 of our guide to helping you choose the best network to connect your IoT device to. This one covers non-cellular options, including Wi-Fi, Ethernet, Bluetooth, 2 newer wireless entrants, SigFox and LoRa, and 2 choices that are commonly used in industrial and remote applications, satellite and private radio. Without further delay, on to the webinar. To get us started, here's a bit about me. I have been in the field of what is now called IoT for about 20 years, working in a variety of areas that has given me a unique level of exposure to assist people in their IoT journey. If I may, I encourage you to check out our weekly IoT podcast, The Internet of Things Made Simple, and you can check out hundreds of IoT-focused blogs at novotech.com/blog. I don't want to make this too much of a sales pitch, but I will say that Novotech has also been in the IoT space for about 20 years and is in a good place to help you with any aspect of your IoT journey. Now, without further delay, here is part 2 to your guide to picking the best IoT network for your application. Now, as if it wasn't confusing enough, we're adding 7 additional choices to being able to connect your IoT devices, in addition to the 7 cellular options that we covered in part 1. Thanks for making it simple, Larry. A few important things to remember. First, you are not locked into a choice for a product or if you introduce a variation of your product. Some people may opt, as an example, to connect a consumer-grade offering to a smartphone via Bluetooth, while another version may be connected via Wi-Fi that is intended for business use. Finally, if you decide your industrial version may not always have Wi-Fi available at a site, you can opt to choose one of the cellular options. Most IoT platforms have no issue receiving data from multiple methods, giving you the flexibility that you need. As well, many manufacturers have products, either cellular routers or modules, that allow you to easily change out to another technology if and when your needs change. Finally, while we have listed a number of applications, both in Part 1 and here in Part 2, where a certain technology may be ideal, these are definitely not the only applications it may be good for. In some of these applications, as many as 10 to 12 choices may work, so you can often stick with your preferred method for many different deployments. Over the past few years, Wi-Fi has emerged as the most common way that people access the internet while at work and especially while at home. It gained incredible acceptance as allowed us to work more freely, like when you sit in front of a TV and play with your iPad. The emergence of Wi-Fi has not been without its issues. Early networks were not all that fast, networks often became congested, and security was often a concern. However, many of those things have been overcome, and Wi-Fi shows no sign of slowing down. In the world of IoT, Wi-Fi has 2 distinct roles. First, it connects many devices that are intended to be used in the home, ranging from smart appliances to smart plugs to your Ring doorbell. Second, many gateways have onboard Wi-Fi hotspot connectivity to allow people and devices to connect. This may include passengers on a bus or an EMS attendant now being able to gather information at the patient's side away from the ambulance. The first major advantage to Wi-Fi is its widespread availability in most homes and businesses. This allows for devices to be assured that connectivity is available in many locations. Second, Wi-Fi modules are very low cost, allowing for Wi-Fi to be added to many lower-cost devices. As well, since most Wi-Fi is backhauled on high-bandwidth networks, data usage is often free or close to it, making it an ideal way to send large files, like a video feed from a camera. Its final advantage is that it's easy to connect, as most people have an understanding how to connect a new device onto their network, or in the case of my parents, they just ask me. On the negative side, Wi-Fi has a drawback in IoT, and it's not for the user, but for a manufacturer. In the case of some wearables, the user sees sending information up to the cloud as a major benefit, so they'll be sure to keep the device connected. However, if the data being sent from the device is meant for the manufacturer, such as usage data, most users will not feel the need to connect the device to the Wi-Fi network, meaning they will constantly be left unconnected. For this reason, expect manufacturers to look at low-cost cellular options like Cat-M going forward. The second negative is the lack of Wi-Fi coverage for temporary events or locations. This is being solved more and more as companies are using Wi-Fi-enabled cellular routers, but this does not mean that Wi-Fi is ideal for unknown locations. In terms of applications, the first one that jumps out for Wi-Fi is any smart home device. There's a lot of talk that cellular networks could be used, but I think Wi-Fi will dominate here for a long time. Fixed large office equipment, so think printers, scanners, and HVAC units, make a lot of sense to connect via Wi-Fi, as they are both not moved often, and the user will see value in keeping the device connected. It will be interesting to see how many tablet manufacturers adopt 5G as the key method of accessing the internet. Some tablets, like iPads, do have an option for cellular connectivity, but most users will still access the internet using Wi-Fi for the time being. Finally, smart health devices will continue to use Wi-Fi. It may be in a dual radio deployment, like in the case of a watch that has both embedded cellular and Wi-Fi capability, or it may be a smart scale that uses only Wi-Fi. Again, time will tell how much emerging cellular technologies, like Cat-M, have an impact here. I have to admit, I have not totally ditched the cable. I still use Ethernet for my main computer. Yes, I do run a Wi-Fi network in the house, but since I do a lot of real-time video conferencing, as good as Wi-Fi has become, the latency is much better when wired. Ethernet is far from dead, especially in the world of IoT. Millions of devices connect to cellular routers via Ethernet ports. So, as a technology, it is going strong. However, as a primary method of connecting your device to the internet, it is becoming less and less common. As mentioned, it is still the method which offers the lowest latency to connect to the internet, making a hard wire into your router the ideal way of connecting fixed applications, like routers, medical machines, and more. Part of its appeal is both a pro and a con, as you will see. On the pro side, many people feel comfortable with the physical connection between devices. Maybe they played that telephone game with cans and string as kids too much, but many people still prefer it over wireless connections. Finally, as much as there are ways to secure Wi-Fi networks, many security experts like the idea of a hardwired connection. This is the case for most servers and high-value devices. As mentioned, the wire is both a pro and a con. On the con side, wires can be cut, whether it's accidental or on purpose. Ethernet cables can be made tough, but most are prone to damage. As well, there are limitations to Ethernet cables in terms of length and the cost to run them. Most deployments using Ethernet assume your building is pre-wired, which is less and less common now. In terms of applications, it is still dominant in connecting routers and most high-end computing devices. I was in a hotel a while back, and I was struck to see how their main connection method to the internet for guests was still a hardwired connection. Can you imagine? No Wi-Fi in the room? Luckily, I had a laptop, and that was fine. Most computing devices still have Ethernet connectors as standard, but that's starting to change, mostly driven down by the need to thin down devices. Although many of us use wireless point-of-sale devices, either at our table in the restaurant or with a delivery service, the majority of point-of-sale in retail is still connected via hardwire. In short, Ethernet is still a common technology for connecting to cellular routers, but less and less devices are using it as a primary method of accessing the internet in the home and in the office. The continued growth of Wi-Fi and the expected growth of 5G will further lead to its demise. Bluetooth. Way too much of my life has been spent trying to pair headsets, headphones, or speakers using Bluetooth. While it has gotten so much better, it is annoying when it does not want to connect. However, it has definitely emerged as the ideal short-haul network between devices when cost may be a factor. I expect Bluetooth to keep on being added to more and more devices. Its low cost for components allow Bluetooth to be put into so many devices in our life. As speeds and costs continue to improve, expect this to continue. Despite my initial frustrations, Bluetooth has become more stable and easy to set up. It has also become more secure, allowing for it to be used in more situations. Finally, its relatively low power use allows for it to be used in battery-powered situations, where maximum battery power is needed. On the negative side, since Bluetooth requires some sort of computing device to access the internet, like a laptop, phone, or tablet, it is not ideal for standalone or real-time applications that may not have a device present. As well, while some industrial versions of Bluetooth have surprisingly long ranges between devices, Bluetooth is somewhat limited in terms of how far it can connect devices. The first ideal application for Bluetooth is when you expect the device to pair up with the network to work, like in the case of a wearable that will pair with a smartphone. As well, another ideal application for Bluetooth is when it's used in an asset monitoring solution as part of a hub-and-spoke setup. Simply, a gateway connects to the internet using wired or wireless and to all the assets via Bluetooth. This may be a car dealership tracking keys or a warehouse tracking skids. In the case of industrial Bluetooth, it is commonly used in communicating with medical devices in hospitals. Finally, as most cars are moving towards adding onboard connectivity, Bluetooth may be an option for some in-vehicle devices when you are planning on using the car's internet connection to access the internet. One of the lesser-known entrants into the world of IoT is SigFox, which has some serious potential to be a dominant network, as long as you can live with some of its limitations. Many will be able to do so, but it's a network that you definitely want to do some research before considering. On the positive side, it excels in sending very small bits of data across the network. If your application is quite simple in nature, like just getting the daily basic update, it offers a very compelling offer. Its battery life is extraordinary, meaning that people are seeing times between battery changes that are much longer than we've ever seen, often many years. This reduces the servicing and the cost of devices. On the negative side, it seems to have a lower level of security than many competing technologies. As well, it doesn't take much to exceed its data capabilities, so it is more limited. Finally, while coverage is extensive in many parts of the world, it is not in most areas of North America, so do your research before considering SigFox to ensure you have the coverage where you need it. In terms of applications, SigFox has a similar customer base to many lower bandwidth cellular networks like Cat-M, and especially NB-IoT when it comes out. The first is tracking non-powered devices, like a porta-potty at a construction site, or a skid being shipped between warehouses. Similarly, it seems to be used a lot in deployments that are slightly below ground, like in the case of buried pieces of electrical equipment. I can also see it having some popularity in tracking some industrial equipment, like compressors or valves. Finally, it should compete well with Cat-M when it comes to tracking some deliveries, but I do see this more for tracking packages as opposed to vehicles, as SigFox is not designed to work with objects in motion. The second of the lesser-known, non-cellular options is LoRa, which is short for long range. It has definitely started to gain some momentum, so depending on your situation, it is very likely one on your radar. The first upside is the extensive group of companies that have shown support for this technology, including Cisco, IBM, and a few more. This likely means it should have some good backing, and it gives comfort for developers to invest time in this technology. It also looks to be quite secure, offering very high levels of security and encryption. This puts it on par with what most companies are looking to use. It looks to be ideal for many lower-cost applications. Some estimates are that, for example, it can offer tank monitoring solutions with hardware costs as low as $40 and ongoing costs of just $2 a month or less. This may open up new markets that may not have been cost-effective to monitor before. On the negative side, it's not a speedster, limiting its capabilities mostly to simple monitoring. As well, it has a relatively high level of latency, making it not ideal for real-time applications. Speaking of applications, many municipalities and regions are looking at or have deployed LoRa networks to monitor key assets like lighting systems and water levels. Assuming you have coverage, LoRa may be ideal for agricultural applications like watering system monitoring and the monitoring of level of moisture in soil. Environmental monitoring, as I have mentioned before, is a wide-ranging topic. It can be things like temperature monitoring, pH level monitoring of a river, and measuring particles in the air. LoRa would be ideal to monitor these kind of deployments. The last type is smart metering, like utility companies monitoring key assets in the field. Finally, if you watch the first part of this series, you may have picked up that many of these applications could also be done using technologies like Cat-M, and that is true. There is a lot of overlap. So if you're doing low bandwidth, simple monitoring, you're going to want to do some research. With LoRa, one of the biggest issues may be coverage. So depending on where you live, be sure to do research into that before moving forward. If you literally need a technology to work at the end of the Earth, you're going to be drawn to satellite technology, as it covers oceans, rural, and mountain areas, and just about everywhere else. Not all satellite networks are the same. GEO satellites are fixed over one spot and often are used for higher data speed applications. Lower Earth ones fly relatively close to the Earth, making them ideal for relatively real-time applications like voice-based traffic. Medium Earth orbit systems operate much higher above the Earth and offer much higher data rates than lower ones. There are other ones as well, including ones designed for TV. The first benefit, as we mentioned to satellite, is coverage. No cellular network will ever approach the thorough level of coverage worldwide that a satellite network can offer. For most applications, especially simple IoT, the data speeds available from satellite are good enough. It won't compete with 5G, but it's more than enough for most monitoring and simple IoT applications. On the negative side, satellite communication has a higher latency than many cellular networks. Now, many IoT applications aren't materially affected by latency as we pointed out, so this might not be an issue after all. Finally, especially with the lower cost of cellular data for IoT with the new networks that have just been announced, satellite data can be much more expensive. Satellite has always done well in markets where, for the most part, it was the only option. As an example, if you were tracking a container across the ocean, it is your only true option. Similarly, if you're tracking a long-haul truck, although cell coverage has vastly improved, satellite is an ideal fallback for areas where it is not available. In terms of fixed applications, oil and gas has been a long-time customer of satellite communications for most of their business. This includes tracking vehicles, but I want to talk about SCADA applications like monitoring oil wells and equipment. They used it because satellite just worked. There was no need to worry if there's a cell tower nearby. Finally, if your workers truly go everywhere, like a forestry worker or a disaster recovery crew, the only way that you could monitor if they were safe was to consider satellite, as it works in all of the areas that they do. In short, I look at satellite as being ideal in two scenarios. First, if your deployment is nowhere near cell coverage, think offshore drilling, extreme remote areas of mountains and deserts. Second, if your solution truly needs to work everywhere, satellite is the best option to make that happen. About 2 decades ago, I got my first exposure to private radio networks as we were trying to convince a police force to use cellular data to transmit key information. Now, that seems dated, as virtually all police forces have incorporated cellular data in some form or another. Before that, all data and voice traffic was sent on closed private networks. Private radio, or private network IoT, is still quite big, not only in public safety, but in areas like mining, oil and gas, and many remote and industrial applications. It is the optimal choice for many low-power applications, like those extremely remote ones. It's often easier to find support for many industrial protocols and port options, although I will say that many industrial-grade cellular routers now have made their way into this space and can often compete very well if there's cell coverage. One recent trend has emerged: private LTE networks. These may be ideal for cities, police forces, and utility companies. On the negative side, you're running your own network. Do you have the time, expertise, available land for towers, and redundancy plans to do such a thing? Depending on what you're doing, you may find your selection of devices is much smaller than on other networks like 4G or Cat-M. In short, the idea of having your own network is something that many will investigate, but few will move forward on. With cell carriers offering better speeds, capacity, and coverage than ever before, it has become a difficult business case to make. However, if you're looking for maximum control and security, and have the willingness to put in the effort, it may make a lot of sense. This includes a municipality. Many have looked at networks like LoRa, while other ones are looking to launch their own LTE network for workers. It will be interesting to see how many do this with the upcoming launch of Band 14. Similarly, many utility companies have hundreds of thousands of assets in a particular city. Most use a combination of short-haul radio and cellular to bring the data back for processing. It'll be fun to see which way they go. Do they stick with what they have? Do they embed Cat-M? Or do they run their own network? As mentioned earlier, hub-and-spoke applications have many assets that all use the same connection point to get access to the internet. However, unlike the example of a car dealership looking for their keys, some assets in the field can be miles apart. I think some may choose to use private radio technology to backhaul the data from the remote device to the hub. Finally, we always talk about how IoT is all about data, but it's important to remember that many deployments use a combination of voice and data, like in the case of a remote police officer. Private radio is still preferred by many for voice-based traffic. I'm curious to see how many new cellular technologies, as well as offerings like SigFox, change the mind of many companies when it comes to running their own networks. Here's a rough comparison between the networks when it comes to 4 important categories. One important thing to remember about several of these technologies is that the technology may contain a number of wide variables. As an example, satellite communication comes in both high-speed flavors and low-speed ones. Data speed is an example of something that everyone thinks they need as much as possible, but most IoT applications are not speed dependent. If you're sending video, sure, you need a fairly high bandwidth pipe, but most IoT applications are lower bandwidth where speed is not a factor. As always, consider what you might need now and what you might need in the future. If you're only ever doing simple monitoring, you can get away with a network like SigFox. But if you think you might want to add video, it becomes a bad choice very quickly. Latency is something that often has little impact on your application. If it takes one of your team members 10 minutes to get out to a site, then will adding an extra second or two for the alarm really make a difference? Probably not. However, if you're doing a real-time application, like a security one, the longer latency from a technology like satellite may make a difference. I'm starting to see a pattern here. Power usage matters in many applications, like tracking devices and long-life battery asset monitors. However, if you're connecting to a power source that also powers a large compressor, I doubt the power consumption from a gateway would make a difference depending on the technology. In terms of cost, it's important to note that you need to factor in internet connectivity into some of these choices. A technology like SigFox or satellite will handle the reporting of a device on its own, whereas Bluetooth-based connections require a donor device to have internet connectivity. If your customer is expected to provide it, this may not be a factor. As always, remember you can always do a split deployment using any of these technologies and even the 7 cellular-based ones in Part 1. Yes, you're finally done. Many thanks for taking time out of your busy day to learn more about IoT networks. We look forward to having you join us for future webinars. Novotech is a great place to start your IoT journey. We have a lot of great material on our webpage, offer industry-leading service and expertise, and a local presence through our vast reseller network. I do ask that you follow us on Twitter, LinkedIn, and YouTube. Thanks again. Take care.